Hello everyone. Today let us learn the Prim's algorithm. So the question for the lab is implement and analyze Prim's algorithm and find minimum cost spanning tree of a given connected undirected graph. So in the question they have given as connected undirected graph. So what it means? So all the nodes must be connected. It's not like you should have the edges for all the nodes, but all the nodes should be connected, which forms a graph. And the second thing is undirected. So you should not have any directions for the edges. So this is a connected and undirected graph. So for this, we are going to find the minimum cost spanning tree. So what is minimum cost spanning tree? You are going to find the edges with the minimum cost or the least cost where all the nodes will be visited. And it should not form any of the loops. Okay. So now, what is the condition for this? As I told in the previous video, consider if we have n number of nodes, then n minus 1 number of edges will be present in the minimum cost spanning tree. And this Prim's algorithm will follow the greedy technique. What is greedy technique? Which always aims for the best solution. If maximization problem means it aims for the maximum solution. If minimization problem means it aims for the minimal solutions. Okay. So here the program starts. So first hash include stdio.h. It is used as a precursor directive for printf and scanner. Main function n number of edges. Array of 2020 means it is a two-dimensional array to store the matrix. Ij for looping. Minimum is for storing the minimum edge in the loop, and the minimum cost is for storing the total minimum cost of the tree. U and V are used as the intermediate variables. N means for next edge and visited means whether you have visited or not, you are going to keep count. Why we need this? Because once you have visited one particular node, you no need to again visit that particular node. That's why. Next, enter the number of nodes. So you are going to accept the nodes and you are going to store in a variable called as n. Then all the nodes at the first time it will be 0. Means what I have not visited any of the node. So you are going to create an array called as visited and you are going to initialize all the values to be 0. Now, first you are going to enter the cost matrix. So what you are going to do, you are going to convert this into the matrix and you are going to enter inside this graph. So consider if it is 0, then automatically it will convert it into 999. So when you are going to give 0, whenever you have some self loops or whenever you are having no path, then you are going to give the 0 in the matrix. So that will be later converted into 999 automatically in the program. So now you need to start somewhere, right? Means some node you should have to start with the finding of minimum cost. So you can start with the node 1 that is left to you. You can select even the different source vertex also. So here what I'm doing, I'm starting from the node 1. So I'm initializing my whether I have visited for that node. So visited of 1 equal to 1. And next edge equal to 1. Why? Because I'm trying to find the next edge. That's why. Minimum cost I'm initializing to 0. While next edge is less than n. Why we are taking here less than? As I told the condition, the number of edges in the minimum cost spanning tree will always be less than the number of nodes. Okay. That for loop, again inner for loop, that we are going to compare whether it is less than minimum and also I should not have visited that. If both conditions are true, then we are going to exchange the minimum and you are going to assign that I and j values to u and v. This you are going to continue in a loop. Next, if my visitor is 0, means what? If I have not visited that particular node, then I'm going to print that whatever the new edge I have found. And that value I'm going to add it for the minimum cost and I'm going to increment my next edge. And visited of V, I'll make it as 1. Why? Because if it is not visited, I'm considering that edge and I'm adding that. So when I'm adding that, it must be visited now. So that's why I have changed here 0 to 1. Now, since consider if I have visited from 2 to 3, then I no need to visit again from 3 to 2 because it is unidirectional graph. So that's why E of UV is equal to E of VU equal to 999 means I no need to consider that for the next loop. Okay, so this will be repeated. So finally, we are going to print the minimum cost. So this is how the output looks like. This is your graph. We are going to enter how many number of nodes. We have taken the same graph for Prim's algorithm and Kruskal's algorithm so that you will get the same output even if you execute any of the one of the method. Okay. So you're going to give the input and you're going to get the minimum cost as the